Hello friends, Mr. Burrell here. We've just started Unit 4. We talked in our last lesson on factoring and solving quadratics. We introduced it, we reviewed it a little bit, did a couple problems walking through the individual steps. In this second part of this lesson, in this video, we're going to continue talking about factoring and solving quadratics. We're going to do a few more examples so we can feel a little bit more comfortable with it. We're going to talk about some kind of cool, unique circumstances that pop up when we're factoring quadratic expressions. And we're going to talk about solving those quadratic expressions. We've talked about factoring them. Now we're going to go on and talk about solving them, because that's what we're all about in when we're talking about polynomial functions. We're all about solving, finding the solutions to those polynomial functions. So just as a reminder, here are the objectives for this lesson. These objectives we've kind of covered already: putting a quadratic equation in standard form, finding the greatest common factor, identifying a, b, and c, and finding two numbers that multiply to a, c, and add to b. And we've talked about factoring a quadratic equation. Today, in this lesson, we're going to review that and go over some more examples and factor a few more different kinds of quadratic functions. And then we're going to talk about, today in this lesson, we're going to talk about finding the solutions of a quadratic once it's in factored form. Some kind of cool patterns and shortcuts that we notice as far as factoring goes and difference of squares. I'll talk about what that means in this video. So again, some of the additional standards associated with this concept is making sense of problems and persevering in solving them, looking for and making use of structure like identifying patterns, and looking for and expressing regularity in repeated reasoning. So reasoning that is repeated. So the processes that we follow, looking for the similarities in each of these processes as we look at a bunch of different kinds of quadratic functions. So let's practice. I have the steps that we identified last time for factoring quadratic expressions over here on the left. And we're going to go over a couple of these examples. Now, walking through these steps in order to factor this quadratic expression. So taking it from this form where it's in standard form into factored form when I have two sets of factors or two sets of parentheses being multiplied together. So first step when I am factoring quadratic expressions is I need my quadratic to be in standard form, which in this case it is, going from increasing to decreasing according to the exponents. My next step, so I can cross that step off, my next step is finding a greatest common factor. So between all three of these terms, you'll notice if I write these all out, 3 times x, 2 times x, negative 1 times 2 times 2 times 2, I don't have a greatest common factor. I've written out the prime factorization of each of these terms, and I don't have anything in common between all three, so I don't need to take out a greatest common factor. Now I need to find two numbers that multiply to get AC and add up to B. So when my quadratic is in standard form like this, here's A, here's B, here's C. So if I multiply A and C together, 3 times negative 8, I get negative 24. So I'm trying to find two numbers that multiply to make 24 and add to get B, or add to get 2. So I need to find two numbers that multiply to make 24 and add up to 2. So let's list all my sets of numbers that multiply to make negative 24. Well, negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6, negative 5 times nothing, negative 6 times, so these are all the first ones. And now, if I have negative 1 times 24 making negative 24, I'm also going to have 1 times negative 24, 2 times negative 12, 3 times negative 8, and 4 times negative 6. And after we go, obviously 5 isn't a factor of negative 24. Once we go on to 6, we start repeating ourselves right here. So those are all my factors. Now I need to see which of those sets of numbers, which of those factors add up to 2. Well, negative 4 plus 6 adds up to 2. Hey, look at that. So those are our two golden numbers here, negative 4 and positive 6. Okay, now step 4. I'm done with step 3. Step 4 says write the factors in this form, filling in blanks with the numbers my golden numbers from step 3. So this is step 3. Step 4, I need to write my factors like this. X plus blank over A times X plus blank over A, where A in this case is 3, and my golden numbers are -4 and 6. Okay, so that's step 4, done. Step 5 says reduce any fractions to simplest form. Well, -4/3, I'm going to go ahead and write this as -4/3 because plus and negative is the same. -4/3, that can't be reduced. 6/3, 6 divided by 3, well, that's 2. That can be reduced. So I've reduced all the fractions I can. Step 6 says bottoms up. Transition this A that's in the denominator and move it to be multiplied by X. So this is the only fraction that still has a denominator or something in the bottom. So I'm going to go ahead and write that as 3x minus 4, because this 3 moves to be multiplied by the x, multiplied by x plus 2. So that's step 6. Transition from that factored form to put that A up in front, bottoms up. Now step 7 is if I remove the greatest common factor in step 2, don't forget to put it back in front. Well, I didn't take out a greatest common factor, so I'm done. This is my final answer. 3x minus 4 times x plus 2. Now, let's go ahead and multiply these together. On this one, we'll do this. Multiply these together to make sure we actually did it correctly. So 3x times x and 3x times 2, -4 times x, -4 times 2. So that's going to give me 3x squared. 3x times 2 is a positive 6x. -4 times x is -4x. -4 times 2 is -8. Notice here are my golden numbers, 6 and -4. And combining like terms, I get 3x squared plus 2x minus 8. 3x squared plus 2x minus 8. And that is indeed what I started with, so I know that I've done my factoring correctly. Okay, there's an example. Let's do another one. I have 6x squared plus 7x minus 3. So first, my quadratic needs to be in standard form, which it is, with the exponents in decreasing order. See that? Done. Step number 2 is finding a greatest common factor. There is not a greatest common factor in these 3 terms, so I can skip that step. Next, I need to find 2 numbers that multiply to make AC and add up to get B. Well, this is A, B, C, since my quadratic is in standard form. So A times C, 6 times -3 is 8, -18. So I need to find 2 numbers that multiply to make -18 and add up to 7. Okay, let's list some factors. So -2 times 9 is 18. I should write this one first. -1 times 18, -2 times 9, -3 times 6, -4, no, -5, no. And if I go to -6, I'm starting to repeat myself, so I can stop there. If -1 times 18 is -18, 1 times -18 is also -18, 2 times -9, and 3 times -6. So which of those pairs of numbers adds up to 7? This one right here, -2 plus 9. Okay, so I've found my golden numbers here. So I'm done with step 3. Step 4 says to write the factors in this sense right here. This is step 3. Step 4 says write the factors like this. X plus blank, X plus blank, where the denominator is A, in our case is 6. X plus blank over 6, x plus blank over 6, where those blanks are filled by my golden numbers here, -2 and +9. -2, +9. Okay, so I've written my factors like that. Now I need to reduce any fractions to simplest form. So step 5, I'm going to reduce any of these fractions that I can. Well, -2 over 6, notice a 2 goes into both of these numbers. 2 can divide into -2, 2 can divide into 6. So if I divide the top and the bottom by 2, I get -1 over 3. And that is my reduced fraction. I can't simplify that one anymore. Over here, I have x plus, and then I have 9 over 6. Notice that into both of these numbers, 3 can divide into both of those numbers. So 9 divided by 3 on the top is 3. 6 divided by 3 on the bottom is 2. So both of those fractions are completely simplified. So I've reduced my fractions. Now, bottoms up, I need to transition from a in the denominator and multiply that a by x. I need to bring that a up in front of the x. So step 6, this value right here, this value that's in the denominator needs to be multiplied by x, bottoms up. So I have 3x plus negative 1, which is just minus 1. And then in this fraction, I need to bring 2 up in front of the x, and I get 2x plus 3. 3x minus 1 times 2x plus 3. So I'm done with bottoms up here. And step 7 says if you remove the greatest common factor in step 2, don't forget to put it back in front. And I didn't have a greatest common factor, so I can skip that step. So my final answer is 3x minus 1 times 2x plus 3. Now let's multiply those together just to double check that we're not crazy, that we did do it correctly. I'm going to multiply everything in the first parentheses by everything in the second parentheses. 3x times 2x is 6x squared. 3x times 3 is 9x. Negative 1 times 2 is negative 2x. And negative 1 times 3 is negative 3. Notice, here are my golden numbers, 9 and negative 2. And when I combine those like terms together, I get 6x squared plus 7x minus 3, which indeed is what I started with. Good. Okay, we've done some review and practice of those factoring problems. Let's move on just a little bit. So this slide, it says factor the following quadratics and then find the solutions, or the zeros. So after we factor these quadratics, then we're going to need to solve them. That's what we're all about. We're going to go on and we're going to talk about solving these quadratics. So we're going to do one of these so I can show you what's going on. So remember that I don't have the steps lifted off to the side. If you need to use them, you can use your guided notes as a reference, but I'm going to try to start doing it without the guided notes. But I know in order to factor this quadratic, if I'm going to solve it, it first needs to be in standard form. If you notice here, I have ax squared plus bx plus c equals 0. That's a quadratic in standard form. It needs to be set equal to 0. And here I am not set equal to 0. I have 2x squared minus 8 equals 6x. So I'm going to go ahead. I want 0 on this side, so I'm going to subtract 6x on both sides. So I'll take this away. And I'll be left with 2x squared minus 6x minus 8 equals 0. So check. My quadratic is in standard form. That's step 1. Step 2 is I need to take out a greatest common factor. Looking at these three terms, is there a number that's in common, a multiple that's in common between all three of these terms? I'm going to go ahead and take out a 2. If I divide each of these terms by 2, I get x squared minus 3x minus 4 equals 0. And for a second here, as we finish factoring, I'm going to ignore the 2 until the very end, and I'm going to ignore the equation equals 0 part until the very end. So I have x squared minus 3x minus 4. Well, my third step is I need to first identify a, b, and c in this quadratic. So a is 1, b is negative 3, c is negative 4. So I need to multiply a and c together. 1 times negative 4 is negative 4. And I find two numbers that multiply to make negative 4 and add up to negative 3. So let's list my factors of negative 4. I have negative 1 times 4, negative 2 times 2. And then over here I have 1 times negative 4 and 2 times negative 2. These are technically actually the same, aren't they? So which of those pairs of numbers adds up to negative 3? Well, 1 plus negative 4 adds up to negative 3. So that right there must be my golden numbers, 1 and negative 4. Okay, well, awesome. So let's go ahead and move on to step 4. I'm going to write my factors in this form. X plus blank over a, x plus blank over a, where these blanks are filled in with my golden numbers, 1 and -4. 1 and -4. Then a is filled in by this term in front of the x squared, my a term, which is just 1. And anything divided by 1 is just itself, so I don't even need to include those here. So my factors are x plus 1 and x plus -4. My step 5 would be, if I still had any fractions, I would reduce those fractions. I don't have any fractions. So I'm going to go ahead and write this as x plus 1 and x minus 4. And since I don't have any fractions, I can skip step 6 because I don't need to take any numbers from the denominator and bring up in front of the x. So this is my final factored form. Step 7 says I need to put that greatest common factor I had over here back in front. So I have 2 times x plus 1 times x minus 4 equals 0. Okay, this part is what we've already done so far, factoring this quadratic expression. Now that it's in factored form, I am going to be able to solve and find the zeros of this function. Remember, when this quadratic function is in factored form, it's incredibly easy. It's a lot easier to find the solutions, to find the zeros, than when it was in this form. So here, remember, the zero product property says that if I have all of these terms being multiplied together in their solution, their answer is 0, that means one of these terms has to be equal to 0. Well, 2 will never equal 0, so I'm going to ignore that for a minute. X plus 1 could equal 0, or x minus 4 could equal 0. In order to solve for x here, I subtract 1 on both sides, and I get x equals -1. In order to solve for x here, I add 4 on both sides, and I get x equals 4. So my solutions are x equals -1 and x equals 4. If I wanted to double check that I did that correctly, I'm going to go back to my original equation, my original expression right here, 2x squared minus 8 equals 6x. I'm going to plug both of these answers in and see if this equality, this left side of the equation, is actually equal to the right side of this equation. So let's plug in x equals 4 first. So 2 times 4 squared, I'm going to put 4 in there for x in parentheses, minus 8 equals 6 times 4. Well, 4 squared is 16, times 2 is 32, so I have 32 minus 8 equals 24. 32 minus 8, indeed, is 24. 24 does equal 24. I must have done that correctly. Now let's check. Let's double check -1. So I'm going to plug -1 in here for x and see if I still get an equal expression. -1 squared is a positive 1, which gives me 2 times 1, which is 2, minus 8 equals 6 times -1, which is -6. And 2 minus 8, indeed, is -6. So I know I must have done that correctly. I've double-checked both my solutions, and they do, in fact, work. So now that we've talked about all the factoring stuff, this is where it starts to come into play. This is where it's important. This is where it matters in solving these quadratic equations, finding these solutions. Okay, so now that we've talked about all the factoring, I'm going to express kind of a little shortcut. So anytime that a is equal to 1, we can find the two numbers, the two golden numbers here, and then automatically write those numbers in the factored form. So I'll show you what that looks like. Remember, we just did this equation right here, 2x squared minus 8 equals 6x. And I determined that after I took out a greatest common factor, I had x squared minus 3x minus 4. That's right here. So once I got this into standard form and took out a greatest common factor, I had x squared minus 3x minus 4. Well, in this case, when I write out A, B, C, when I write out my quadratic in standard form and I identify A, B, and C, I notice that A is equal to 1. So when A is equal to 1, when I don't have anything in front of the x squared, I can now identify kind of a shortcut, a little shorter way that I can finish factoring this. Once I find those two golden numbers, I can automatically write those numbers in the factored form. Factored form meaning this, x, x, and then I'll be able to write those numbers right here. So my two numbers that multiplied to make -4, my two numbers that multiplied to make -4 and add up to -3, if we go back here, those two numbers were 1 and -4. So those two numbers are 1 and -4. Well, that ended up being my final answer, x plus 1 times x minus 4, with this 2 in front as the greatest common factor. So the reason that works out so well is because in the step where I have to divide by a, because I'm dividing by 1, those factors are not going to change. So that's kind of a handy shortcut that you can sometimes use. It's not a necessary shortcut, but it's a handy shortcut sometimes when our quadratic function has a very first coefficient, this a value, being equal to 1. You notice that would work in this problem. It won't work in this problem because when I get this into standard form and I add 6 on both sides, so I have 6x squared plus 5x plus 6 equals 0, there's no greatest common factor, and this first term is not 1. So I can't use that shortcut here. Don't get hung up on this shortcut. As you get better and more efficient at factoring quadratics, that can come in handy. Don't worry too hard about it right now, but just know that that's handy for you if you want to use it. Okay, one other thing, the main reason that we talk about this is called the difference of squares. The main reason we talk about this is because sometimes it does pop up on the ACT, the difference of squares formula. So the difference of squares formula says if I have a function like this, x squared minus c squared, then the factored form of that function is going to be x minus the square root of c times x plus the square root of c. For example, if this was x squared minus and this was c squared, if c squared is 25, then if c squared is 25, then c is going to be the square root of 25, which is 5. So the solution, the factored form of that quadratic expression, when I just have an x squared term minus a perfect square term, is going to be x minus 5 and x plus 5. X minus the square root of c, x plus the square root of c. And this should really be just c here, since I have c squared here. So x squared minus 25 is equal to x minus 5 times x plus 5. If I multiply those together, just to double check, I get x squared plus 5x minus 5x minus 25. And notice my like terms here in the middle, 5x minus 5x is just 0. So I'm left with x squared minus 25, which is indeed, what I started with. You can solve these problems the same way that we have our other problems, but this again is kind of a handy pattern to recognize that you can start to see pop up in some of these different questions. So for example, let me erase this real quick. Right here I have 4x squared minus 36. So my factored form right here is going to be the square root of this plus the square root of this, and then the square root of this minus the square root of this. Okay, so the square root of 4x squared, if I square root this, the square root of 4 is 2. The square root of x squared is x. The square root of 36 is 6. So when I have 4x squared minus 36, that's why this is called the difference of squares. I have two perfect squares here. So if I have a difference of two perfect squares, I get 2x plus 6 times 2x minus 6. And that trick is only helpful if I have a difference of squares. So again, this is one that's not necessary to memorize, but sometimes this does pop up on the ACT on certain tests like that. But that would be my solution, or that would be my factored form, 2x plus 6 times 2x minus 6. And then I would set each of these terms equal to 0 in order to find my solutions. Reminder, and we'll go over this one real quick, this definition. Remember that we have been factoring so that we can find solutions to quadratic equations. Quadratic equations have two solutions. The whole reason that we're doing this factoring is so that we are going to be able to solve, and that's what we've just been doing. So, for example, when I have this quadratic function like this, x squared minus 5x plus 6, when I factor it out, I get x minus 2 times x minus 3 equals 0. Again, this is so much easier to solve when I have two factors multiplied together set equal to 0, because I can set each of those individual factors, x minus 2 and x minus 3, equal to 0. And when I solve for x here, I get x equals 2 and x equals 3. That's why I factor quadratics, so it can become easier to solve those quadratic functions. Okay, so there's some homework problems here. So if you're feeling good, you can skip the last part of this video, but I'm going to do a couple of homework problems. I'm going to do number 15 on your homework. This is 2n squared plus 28 equals 18n. So first I need to, in order to solve this, I'm solving this quadratic, but before I solve it, I need to put it in factored form. So in order to factor this, I need it to be in standard form. So since standard form is ax squared plus bx plus c equals 0, I need to subtract 18n on both sides so I can set this side equal to 0. So standard form is 2n squared minus 18n plus 28 equals 0. Okay, I'm going to ignore this equals 0 till the very end. I'm just going to worry about this quadratic that I'm factoring. Step 2, I need to find a greatest common factor. In this question, I have a greatest common factor of 2, because there's a 2 in common in all three of these terms. So when I divide each of those terms by 2, I'm going to get n squared minus 9n plus 14, just like that. Okay, so now, looking at this quadratic, n squared minus 9n plus 14, here's a, b, and c. I'm going to multiply a and c together. 1 times 14 is 14. And I need to find two numbers that multiply to make 14 and add up to negative 9. Well, my factors of 14 are 1 and 14, 2 times 7, then negative 1 times negative 14, and negative 2 times negative 7. Well, negative 2 and negative 7 do indeed add up to negative 9. Negative 2 minus 7 is negative 9. So those are my two golden numbers. So step 4, I need to write my factors like this. X minus 2 over a, which is 1, and x minus 7 over a, which is 1. Well, remember my shortcut, since a is equal to 1, I don't even really need to write those fractions because anything divided by 1 is just itself, and my factors end up being x minus 2 times x minus 7. So I've just skipped all the way down to step 7. Those are my factors, x minus 2 times x minus 7. 7 says I need to make sure and put this greatest common factor back out in front. 2 times x minus 2 times x minus 7 equals 0. Now that it's in factored form, I'm going to go ahead and solve. Because I have all these factors being set equal to 0 being multiplied, x minus 2 could be equal to 0, or x minus 7 could be equal to 0. When I solve for x in each of these equations, I get x equals 2 and x equals 7. Those are my two solutions to that quadratic function. Again, that's number 15 on your homework, so those would be my answers. And to double check, you can plug 2 and 7 back in here for n, and make sure that you actually get two sides of the equal sign that are indeed equal to each other. Okay, I want to do one more. This one's number 18. This one looks a little bit intimidating, which is why I wanted to cover it. So, to start, I need to make sure that my quadratic equation is in standard form. Ax squared plus bx plus c equals 0. So, in order to do this, I'm going to go ahead and add 3 on both sides so I can make this side equal to 0. And I'm going to subtract 6v on both sides so I can set that side completely equal to 0. which leaves me with 49v squared. Negative 15 minus 6 is negative 21v. And negative 1 plus 3 is a positive 2. That's all set equal to 0. So that's my first step as I wrote it in standard form. 49v squared minus 21v plus 2. Now, my second step is I need to take out a greatest common factor if I can, but I can't. In this function, there's not a greatest common factor, so I'm just going to leave it as is. Question 3, I need to multiply a and c together. So here's a, b, and c. I need to multiply a and c together, which is 49 times 2, which is 98. So I need to find two numbers that multiply to make 98 and add up to b, or negative 21. So I need to find factors of 98 that add up to negative 21. That's a big one. So let's see. I have negative 1. I have negative 1 times 98. I have negative 2 times, what's 98 divided by 2? 49. Negative 2 times 49. Negative 3 times nothing. That's not going to work. Negative 4 times nothing. All of those aren't going to work. 6 isn't going to work. 7 is going to work. I'm going to have 7. Oh, all of these should be positive. I apologize. I have 7 times 14. And I'm checking these in my calculator. 98 divided by 7 is 14. So 7 times 14 is 98. And that's as far as I need to go. Conversely, negative 1 times negative 98 is a positive 98. Negative 2 times negative 49 is a positive 98. And negative 7 times negative 14 is a positive 98. Well, which of those pairs of numbers is going to add up to negative 21? This one. Negative 7 plus negative 14, or negative 7 minus 14, is negative 21. Okay, well, let's go ahead and go to step 4, which says I need to write my factors like this. X plus blank over a, x plus blank over a, where a is this first number here in standard form, which is 49. 49. My numbers on top to fill in the blanks are my golden numbers, which are negative 7 and negative 14. Okay, step 5, I need to reduce those fractions. So I have x minus, this plus and negative turns into a minus. Note that here, a 7 will divide into negative 7, and a 7 will divide into 49. So if I divide the top and bottom of this fraction by 7, I get negative 1 over 7. Conversely, over here, I have negative 14 divided by 49. 7 will also divide into both of those terms. Negative 14 divided by 7 is negative 2. 49 divided by 7 is 7. And if I write that with just one sign, I get x minus 1/7 and x minus 2/7, because these were both negative numbers. My golden numbers are both negative. So step 6 says bottoms up. Any numbers I still have in the denominator need to be written up in front of the x here, which gives me 7x minus 1, in parentheses, times 7x minus 2. And then step 7 says if I have any greatest common factor to put it back, which I don't. So I have 7x minus 1 times 7x minus 2 is equal to 0. So now the zero product property states that if I have these two factors multiplied together and they're equal to 0, that one of the factors or both of them has to be equal to 0. So I'm going to set both of these factors equal to 0. So I'm going to go ahead and add 1 on both sides on this first one. And that gives me, this is an arrow, 7x equals 1. Then I'm going to divide by 7 on both sides and get x equals 1/7. So that's one of my solutions. This one I'm going to add 2 on both sides, and I get 7x equals 2. I'm going to divide by 7 on both sides. I'm going to get x equals 2 over 7. I can leave those as fractions there. And those are my two solutions. Not all the problems will be this intense, will be this crazy, but I wanted to go over one like it so you could see what it would look like. Okay, so that's factoring and solving quadratic equations. So again, hopefully now with these final objectives, hopefully now you feel comfortable, a little more comfortable factoring a variety of types of these quadratic equations and finding the solutions to those quadratic equations once they're in factored form. And I hope you recognize and understand this factoring shortcut and the shortcut associated with difference of squares. Those are not necessary. They're just handy sometimes if you want to pursue them further. So that's factoring. That's a big, big chunk, and we're going to start, now that we've covered factoring and solving quadratics, we're going to extend that into a variety of other higher degree polynomials. So get excited for that. I know I am. Please reach out to me if you have any questions whatsoever. I hope that was helpful. I hope that you enjoyed that video as much as I did.